Hello everyone, welcome to Sangam Tutorials, Cbse online classes for Ncert and Cbse 10th standard for mathematics and science. So for 10th standard classes, we were solving problems on quadratic equations. So some equations were given to you and you were asked to find out whether these equations gives you a quadratic equation or not. So those were the problems. So the same type of problems we are going to continue today also. Some four to five problems, very important. We are going to do it, and after that we are going with some statement problems where we are going to convert those statements into mathematical statements, that is equations, and then reach to the quadratic equation. So today we are going with these type of problems. So let us get into the session. So here same question continues. Check whether the following are quadratic equations, or reduce. This question may be also asked as reduce the following equations to quadratic equations, right? Something like that. So any question can be asked to you. So here we have the first question here, that is x minus 2 whole square plus 1 is equal to 2x minus 3 is the given equation. We have to check whether the given equation is a quadratic equation or not. So just by looking at that, we cannot come to a conclusion that it is a quadratic equation or not. So we have to bring it to the simplified form. We have to bring it to the form of ax square plus bx plus c is equal to 0. Then we will have to confirm if the equation is in the form of ax square plus bx plus c is equal to 0, or if it is in the form of ax square plus c is equal to 0, or if it is in the form of ax square plus bx is equal to 0, then we can conclude that it is a quadratic equation, right? So if it is not in these three forms, we will say that the given equation is not a quadratic equation. So that's the conclusion. So let us get into the problem. So x minus 2 whole square plus 1 is equal to 2x minus 3 we have. So in the LHS we have x minus 2 whole square plus 1, and in the RHS we have 2x minus 3. So here in these type of problem, the first thing to be done is you have to expand the things which is given as a perfect square. So here x minus 2 whole square is a perfect square. So here we have to expand this by using either a minus b whole square formula or a plus b whole square formula, depending upon the sign between the two terms. So we have here minus sign, so this is in the form of a minus b whole square. So we have to expand that. So a square plus b square minus 2 into a into b. This is the expansion. X minus 2 whole square can be written as x square plus 2 square minus 2 into x into 2 plus 1 we are going to write is equal to 2x minus 3. So it is x square plus 2 square is 4 minus 2 into x into 2 is 4x plus 1 is equal to 2x minus 3. So we have to simplify the LHS and then we have to go with the process of that is transposing. So x square plus 4 plus 1 becomes minus 4x plus 5, that is plus 4 plus 1 is plus 5 is equal to 2x minus 3. So now we will transpose this 2x to LHS and also we will transpose this minus 3 to LHS. So that becomes x square minus 4x, which is here. So plus 2x is transposed to LHS, it becomes minus 2x plus 5 remains here. Minus 3 gets transposed, it becomes plus 3. So nothing remains in the RHS, therefore we have to equate that to 0, right? So now simplify the like terms here. So x square minus 4x minus 2x is minus 6x, and plus 5 plus 3 is plus 8 is equal to 0. So this is in the form of a quadratic equation. So this is in the form of ax square plus bx plus c is equal to 0, and the variable's highest degree is 2. Therefore it is a quadratic equation. This is how we have to conclude this, right? For the first problem I am going to write this. So it is in the form of ax square plus bx plus c is equal to 0. Therefore it is a quadratic equation. So full form of this you have to write. So in between you can add the statement. The variable in the equation has the highest degree 2. Therefore it is a quadratic equation. If you write it, okay, it's okay. That's a very good answer, right? So we'll get into the second problem. x square minus 2x is equal to minus 2 into 3 minus x. So now, so it is a textbook exercise problem. So as it stands a little bit different from other problems, I have selected this. So we'll go with this. So x square minus 2x is equal to minus 2 into 3 minus x. Okay. So x square minus 2x is equal to, nothing here to simplify. So therefore I have written the same thing here. So now minus 2 is a monomial, 3 minus x is a binomial. So let us multiply this binomial by this monomial with sign. So it is minus 2 into plus 3, it becomes minus x. Minus 2 into minus x is plus 2x. It's very, very important, right? So now x square. So here most of the students, what the wrong step they do is they cancel this minus 2x and plus 2x. You are not supposed to cancel. So in the LHS, if it is minus 2x, and also in the RHS, if it is minus 2x, then you are supposed to cancel that. So if they are having two different signs, you are not supposed to cancel that, right? Okay. So x square minus 2x plus 2x gets transposed to the LHS, so it becomes minus 2x. Minus 6 comes to LHS, that becomes plus 6 is equal to 0. So x square, so minus 2x and minus 2x are the two like terms because they have the same variable with same degrees. So therefore they are called as like algebraic terms, they can be simplified. So x square minus 2x is minus 4x plus 6 is equal to 0. So this is the required quadratic equation. So it is in the form of yes, it is ax square plus bx plus c is equal to 0. So therefore it is a quadratic equation, right? So it's very simple for 2 marks. Let us get into another one. X square plus 3x plus 1 is equal to x minus 2 whole square. So this problem is similar to the, okay, this problem maybe it looks like similar, right? So it's an equation, we have to check whether the given equation is a quadratic equation or not. So that's very simple. Let us take the problem. X square plus 3x plus 1 is equal to x minus 2 whole square. So x square plus 3x plus 1 is equal to, it is in the form of a minus b whole square. We have to expand that by applying a minus b whole square formula. So it is x square plus 2 square minus 2 into x into 2. That is a square plus b square minus 2 into a into b. Right. So x square plus 3x plus 1 is equal to x square plus 2 square is 4 minus 2 into x into 2 is 4x. So here plus x square and plus x square, these are going to get cancelled, right? So we will see the remaining things. So we have 3x plus 1 here, and at this side we have 4 minus 4x. So let us transpose these two to the LHS. So 3x minus 4x, when it get transposed it is plus 4x, and plus 1 I will write plus 4, when get transposed it is minus 4, which is equal to 0. So 3x plus 4x, they are like algebraic terms, we can add it. So 3x plus 4x is 7x plus 1 minus 4. Plus 1 minus 4, as they are having two different signs, so therefore it can be written as minus 3 is equal to 0. So here 7x minus 3 is equal to 0 we are getting here. So 7x minus 3 is not a quadratic equation because the degree of the variable is 1. So therefore it is not a quadratic equation. So the degree of variable is 1. So therefore it is not a quadratic equation. So very simple. So these are the 3 problems which can be asked in examination for 2 marks. Right, we'll go with the next problem, very important. So it is x plus 2 whole cube. X plus 2 whole cube is equal to 2x into x square minus 1. Right, we'll check it. So just by looking at that, we cannot guess whether it is a quadratic equation or not. We have to solve it, we have to simplify that. When we reach to the last step, then only we can come to a conclusion whether it is a quadratic equation or a cubic equation or a linear equation, something like that, right? So okay, let us get into this. So x plus 2 whole cube is equal to 2x into x square minus 1. Okay, let us expand this. So this is in the form of a plus b whole cube. So a plus b whole cube can be written as a cube plus b cube plus 3ab into a plus b. So that's the formula here. So let us expand this. So in place of a we have x and in place of b we have 2. So a cube is x whole cube plus b cube is 2 cube plus a cube plus b cube plus 3ab. So 3 into x into 2 into a plus b, that is x plus 2. That is a cube plus b cube plus 3ab into a plus b is equal to 2x into x square is 2x cube and 2x into minus 1 is minus 2x. Right? Okay, x whole cube is x cube plus 2 whole cube is 8, that is 2 into 2 into 2 is 8, 2 2s are 4, 4 2s are, it is 8 plus 3 into x into 2 is 6x into x plus 2 is equal to 2x cube minus 2x. Okay, we have to open this bracket by multiplying this monomial with this binomial again. So x cube plus 8 plus 6x into x is 6x square, 6x into plus 2 is plus 12x is equal to 2x cube minus 2x, right? So here we'll simplify this, we'll take this into LHS, we'll take this into LHS, that is transposing. So x cube plus 2x cube when it gets transposed it is minus 2x cube and it is plus 6x square plus 2x, okay, minus 2x when it gets transposed it is plus 2x and plus here we have plus 12x and remaining is plus 8 is equal to 0. So please check out 1, 2, 3, 4, 5, 6 terms. So 1, 2, 3, 4, 5, 6 terms. So nothing should get missed, right? So again x cube, 1x cube minus 2x cube can be simplified. This becomes minus x cube, right? Plus 6x square, nothing is there to get simplified. So plus 2x plus 12x becomes plus 14x plus 8 is equal to 0. So this cannot be simplified further because all are unlike algebraic terms, they cannot be added or subtracted. Therefore the equation remains stagnant here. So here at this point we have to guess or we have to see whether this quadratic equation is a quadratic equation or not. So here the variable x exists here, here and here, but we have to consider only the highest degree of the variable. So therefore the highest degree of the variable is 3. Therefore it is not a quadratic equation, but it is a cubic equation, right? So okay, it is okay, the variable has 3 as highest degree. Variable has 3 as highest degree, so therefore it is not a quadratic equation, right? So I hope you understood this, very important. Let's get into another one. X cube minus 4x square minus x plus 1 is equal to x minus 2 whole cube. So let us check this whether it is a quadratic equation or not. Very important. You have to be very careful. Just you are seeing how carefully I am doing this, because if I miss a single sign or a single term, maybe the answer changes at the last, right? So you have to be very careful. Okay, right. So x cube minus 4x square minus x plus 1 is equal to x minus 2 whole cube, right? So here nothing is there to get simplified, so therefore x cube minus 4x square minus x plus 1, we will write the same thing, is equal to a minus b whole cube. So this is it is x minus 2 whole cube, which is in the form of a minus b whole cube. So a minus b whole cube is a cube minus b cube minus 3ab into a minus b, right? Okay, x whole cube minus 2 whole cube minus 3 into x into 2 into x minus 2, right? That is a cube minus b cube minus 3ab into a minus b, right? So x cube minus 4x square minus x plus 1 is equal to x whole cube is x cube, 2 whole cube is minus 8, that is 2 cube is 8, minus 3 into x into 2 is minus 6x into x minus 2, right? So x cube minus 4x square minus x plus 1 is equal to x cube minus 8 minus 6x into x, that becomes minus 6x square, minus into minus is plus, 6x into 2 is 12x. So now you have a chance, plus x cube and plus x cube on both sides are going to get cancelled, right? Okay, so now we are left over with minus 4x square minus x plus 1 on the LHS, and we are left with minus 6x square plus 12x and minus 8 in the RHS. So we will transpose all the three terms in the RHS to the LHS and then we will simplify again. So minus 4x square minus 6x square gets transposed, it becomes plus 6x square. Here we have minus x, plus 12x gets transposed to LHS, it is minus 12x, and we have plus 1 here. Minus 8 gets transposed to LHS, it becomes plus 8 is equal to 0, right? So it is minus 4x square plus 6x square, like algebraic terms, they can be simplified. So it is 2x square minus 1x minus 12x. So we have 1 here, it's understood. If nothing is there, the coefficient of the variable is 1. So minus 1x minus 12x is?
Minus 13x.
Oh, nice. Minus 13x, still louder. Minus 13x plus 1 plus 8 is plus 9 is equal to 0. So this is the required quadratic equation where it cannot be simplified further. So the variable, it is in the form of ax square plus bx plus c is equal to 0. Therefore it is a quadratic equation. So in these type of problems, why they have given such type of problems here at the beginning of statement problems? It's very simple. When we start solving statement problems, the data what it is given in the problem, when we convert that into mathematics, we don't get directly quadratic equations. We get equations which are in this form. So therefore if we practice these simplifications before entering into statement problems, it will be easy for us to deal with the statement problems, right? So you have to practice this well so that you can do well in the coming statement problems, right? Okay. Right. So before starting continuing with the session, I would like to suggest you to keep mathematics textbook here beside you or in front of you, because I am going to read out certain statements where we are going to convert them into quadratic equations. So the question goes like this: represent the following situations in the form of quadratic equations. So it's exercise 10.1 and second main. Exercise 10.1 second main. So please pause the video, stop the video now, bring the textbook, keep it in front of you, then please continue with the video, right? Okay. Right. The area of a rectangular plot is 528 square meters. Very important, right? Just the problem is given in the form of a statement. We have to check or we have to represent the given situation. Situation is nothing but the statement problem. That situation in the form of a quadratic equation. So here you are going to learn 4 different types of this, which are very important, which will be asked in your examination for 3 or 4 marks. Maybe not for 4 marks, for 3 marks compulsory, they will ask you in the examination. The area of a rectangular plot is 528 square meters. Okay, this is the rectangular plot and its area is 528 square meters. That is the area inside this rectangular plot is 528 square meters. Next, the length of the plot. So this becomes the length of the plot and this becomes the breadth of the plot. Okay, the length of the plot in meters, it is in meters, is 1 more than twice its breadth. That is, the length of the rectangular plot is 1 more than twice its breadth. So here we do not know anything regarding the breadth, but we know regarding the length with respect to the breadth. So therefore we have to guess the breadth. So many students guess the length and make the problem very complicated with the breadth. So therefore, which is not known to you, with whose respect the problem is being carried out, with that particular thing we have to guess it. So here they are speaking about the length with respect to breadth, but regarding breadth he won't give you anything. So in that case we have to guess the breadth, right? So let the breadth of the right rectangular plot be x meters. So the condition is the length of the plot is, the length of this plot is 1 more than twice its breadth. So it is, okay, 1 more than means it is addition, it is plus. So 1 more than twice its breadth. Breadth is x, twice its breadth is, it is 2x. So it is 2x plus 1 meters here. Okay. We need to find the length and breadth of the plot. So this situation has to be represented in the form of a quadratic equation, right? So let us do this. So first we will guess the breadth. Let the breadth be x meters. Then length will be 2x plus 1 meters. 2x plus 1 meters, right? So therefore, as you have to find the length and breadth, and area is also given. So therefore, we'll write the area here. So area of plot is 528 square meters. So therefore, according to given condition, right? So we know that in rectangular plot, length into breadth is equal to its area. Length into breadth of a rectangle is equal to its area. So therefore, area of rectangle is equal to that is x into 2x plus 1. That is length into breadth. So area of rectangle is given, value is given here. So it is 528 is equal to x into 2x is 2x square, x into plus 1 is plus x. So we will transpose this plus 528 to RHS. So it becomes 2x square plus x plus 528. When it goes to the RHS, it becomes minus 528 is equal to 0. So this is the required quadratic equation. So by any one of the method, either by using the sum and product method that is, in other words, it is called as factorization method, or by formula method, or by the Sridhara's method, that is the method of completing the square method, or by graphical method, right? We can find the value of the length and breadth. So here when we solve this, you are going to get the value of x, which is that is two roots you are going to get. That is, for x you are going to get two values. So out of these two values, you have to select the positive value, because length is always positive. From Gubbi to Tumkur, nobody tells you it is minus 20 kilometers. It's never possible. So length is always positive. So you have to select the positive value. So once you get the positive value of x, which will be that? It is the length or breadth you have got. It is the length or breadth you have got.
It's the breadth.
It is the breadth you have got, because you have guessed the breadth, right? So once you get the breadth, you can use that to find out the length, right? So this is how I have represented this situation in the form of a quadratic equation, right? I hope you got the thing, right? Please write down the question from the textbook and write this in your classwork book, right? So please maintain the classwork. Let's get into the second problem. The product of any two consecutive positive integers is 306. We need to find the integers. So this is the given situation. The product of two consecutive, what do you mean by consecutive? Which comes one after the other. That's called as consecutive, right? The product of product is the multiplication. The product or the multiplication of two consecutive positive integers is 306. So positive integers, so negatives are not allowed, right? So two consecutive integers which comes one after the other. So they may be natural numbers, they may be whole numbers, they may be integers. Among integers they may be positive integers, right? They may be rational numbers, anything which are having plus sign. So when you multiply those two positive integers, the product should be 306. So represent this in the form of a quadratic equation. So do you know the integers? Do you know which are the integers? You don't know. But the only thing you know is that they are consecutive. So now, for example, I will take it as 5 and 6. 5 and 6 are consecutive positive integers. So if you take 5 as x, then 6 will be x plus 1. 6 will be x plus 1, because you have taken 5 as x. So 6 will be written as x plus 1, because x is 5, 5 plus 1 is 6. So any two consecutive integers, maybe they are negative, they are positive, whatever it is, any two consecutive natural numbers, any two consecutive integers, any two consecutive whole numbers, any two consecutive, okay, some AP, now in an AP, if D is equal to 1, the condition applies. So any two consecutive, if you hear that, right, then please guess it in the style, that is x and x plus 1. So let the two consecutive integers be x and x plus 1, right? Okay, so we'll get into this. Let the two consecutive positive integers be x and x plus 1. So now the product of these two is 306. Product is 306. So therefore, according to given condition, product of this number and this number which are consecutive is 306. So therefore this can be written as x into x plus 1 is equal to 306. The product of two consecutive integers is 306. Right? I hope you got it. You are understanding? Right. So now x into x is x square, x into plus 1 is plus x is equal to 306. So x square plus x plus 306 when transposed to LHS it becomes minus 306 is equal to 0. This is the representation of the given situation in the form of a quadratic equation. So this is how we go with numericals, that is problems on numbers on quadratic equations. So there are different types of category of problems are based on quadratic equations. Maybe I can summarize it like this: problems on numbers, problems on time, problems on speed, problems on age, problems on geometrical figures, something like that. Many categories are there. So maybe from 4 to 5 categories I can differentiate in your textbook, and I am going to present in the coming sessions. Right? I hope you are enjoying this. We get into the next problem. So which is based on age. The situation is based on age. So you have to convert that situation into a quadratic equation. Right. So go with the problem. This is the third problem. In second main, exercise 10.1. I cannot tell you the page number. This is the old textbook. Okay, anyway, please look into that. Rohan's mother is 26 years older than him. Please understand the situation. Imagine the things. Right. Rohan's mother is 26 years older than him. So here Rohan's mother age is being compared with the age of Rohan. So we do not know the age of Rohan here. So therefore we have to guess the age of Rohan. Right? I hope you got it. Rohan's mother age is 26 years older than him. Do you know the age of Rohan here? Do not know it. You have to guess it. Right? So let the age of Rohan be x years. Let the age of Rohan be x years. Now let us calculate his mother's age now. Rohan's mother is 26 years older than him. So therefore Rohan's mother age will be, so 26 years. She is 26 years older than Rohan. Right? She is 26 years older than Rohan. So therefore it will be x, that is the age of Rohan, plus 26 years. So what is the present age of Rohan? The present age of Rohan is x years, and the present age of Rohan's mother is x plus 26 years. So these are the present ages, today's ages. Today's age of Rohan is x years, today's age of his mother is x plus 26 years. Right? So now let us read the problem. The product of their ages, 3 years from now. So now for example you are 14 years old. From 3 years from now, what will be your age? 14 plus 3. So it is 17 years. My God. Okay. The product of their ages 3 years from now will be 316. So Rohan's age is x years. Rohan's mother age is x plus 26. From 3 years from now will be Rohan's age. To the Rohan's age we have to add 3 years, and to the Rohan's mother age we have to add 3 years. Right? I hope you got it. Right? 3 years ago it was something like that. Then we will have to subtract the 3 from it. But actually situation is like this. The product of their ages 3 years from now will be 360. So let us guess their ages. What will be after 3 years? So Rohan's age after 3 years will be, Rohan's present age is x years. After 3 years it will be x plus 3 years. X plus 3 years. I hope you are getting it, what I am telling you, right? So now, Rohan's mother's age after 3 years will be, Rohan's mother age after 3 years will be. So what is the present age of Rohan's mother? X plus 26. Present age is x plus 26. So what will be her age after 3 years?
X plus 26 plus 3.
Right. So it is x plus 26 plus 3 years. So it is x plus 26 plus 3 is 29 years. Right now. So according to the condition, according to given condition, right? Let us see the condition. The product of their ages, that is, you are going to multiply that. So the product of their ages 3 years from now will be 360. So product of the, okay, Rohan's age after 3 years is x plus 3. Rohan's mother's age after 3 years will be x plus 29. So when you multiply these two ages, then the product will be 360. So that is the condition. So according to the given condition, so x plus 3 into x plus 29 is equal to 360. So this is how we have come to the equation. So these type of equations were given to you in the previous problems. Just now what 4 problems we did, these type of equations were given. You used to multiply and reach to the quadratic equation. So now what they have done, they have went one step behind. So they are giving you situations, you have to convert that situation into an equation and then you have to reach to the quadratic equation, right? So x into x is x square, x into plus 29 is plus 29x, plus 3 into x is plus 3x, plus 3 into 29.
87.
Okay, 29 into 3 is 87. Okay, thank you. Is equal to 360. So x square plus 29x plus, oh, we can add these two terms because they are like terms. So 29x plus 3x is 32x plus 87 is equal to 360. Still more, one step is there. So okay, x square plus 32x plus 87. We will transpose this 360 to LHS, it becomes minus 360 is equal to 0. So x square plus 32x plus 87 minus 360.
Minus 273.
Minus 273. Oh, nice. Minus 273. You are so fast. Very good. So this is the required quadratic equation. Right? So this is how we have converted this situation into the mathematical form, that is the quadratic equation. Right? I hope you are enjoying the problems. Okay, last problem. Right, so this particular problem, this particular situation is based on speed and time. Very important. A train travels a distance of 480 kilometers at a uniform speed. So let us imagine this is point A, this is point B, right? A train starts from A and reaches B at a uniform speed. Uniform speed in the sense a body covering equal distances in equal intervals of time, that the body is said to be in uniform speed. So here the train is said to be in uniform speed. A train travels a distance of 480 kilometers. So what is the distance between A and B? It is 480 kilometers. This is the distance, right? Uniform speed. Speed is uniform. So actually, in technical terms, speed cannot be uniform. If you are going from one place to another place, will the speed of your vehicle or your cycle is uniform? No, it's not uniform. It is non-uniform speed. Okay, let it be. We'll consider that is uniform speed. If the speed had been 8 km per hour less, then it would have taken 3 hours more to cover the same distance. See here, you have to think some physics here. We need the knowledge of physics. So now, for example, if you are covering a distance of 480 kilometers from A to B, you are going at a certain speed every day. But on a particular day, if you are late, but you have to reach the destination B at the same time, then will you increase the speed or decrease the speed? Certainly you are going to increase the speed, right? So now, on a normal day you are going from A to B. Leaving the normal speed, if you go at a higher speed, will you reach the destination earlier or late?
Early.
Yes, you are going to reach the destination early, right? So very simple. A train travels a distance of 480 kilometers at a uniform speed usually. Every day it goes at a certain speed. For example, let us imagine the train is traveling from A to B covering a distance of 480 kilometers at x kilometer per hour. Let the uniform speed be x kilometer per hour. Let us guess it. So let the uniform speed be x kilometer per hour. Right. So what is the distance travelled? So distance travelled is 480 kilometers. Right. Very simple. You have guessed the uniform speed. So let the uniform speed of the train be x kilometer per hour. This is the speed, and the distance travelled is 480 kilometers. So you have two factors with you. One is speed, another is distance. You have speed, that is x. You have distance, that is 480 kilometers. Right. Can you find out the time? Can you find out the time taken by the train from A to B? So you can easily use the speed formula here, right? So speed is equal to SP is equal to distance travelled by time. So speed is x is equal to distance travelled is 480 by time. I want time to be calculated, so therefore by 1 it is x into t is xt is equal to 480. So t is equal to 480 by x hours. So what is the time taken by the train to travel from A to B at a speed of x kilometer per hour covering a distance of 480 kilometers? It is 480 by x hours. This is some hours. 5 hours, 4 hours, 6 hours, something. It is hours. So always time is equal to distance by speed is always hours. In this case it is hours. Right? I hope you are getting this. So t is equal to 480 by x is the time taken by the train at a speed of x kilometer per hour covering a distance of 480 kilometers. Now the condition applies. What is the condition? If the speed has been 8 kilometer per hour less, oh, I am sorry to tell you this, because the train was moving at x kilometer per hour usually, but today something happened and the train is traveling at a speed of 8 kilometer per hour less than the usual speed. Less than the usual speed. So what is the usual speed? It is x kilometer per hour. It is now 8 kilometer per hour less. That means x plus 8 or x minus 8?
X minus 8.
Exactly. It is x minus 8 kilometer per hour. So speed has been decreased. So speed is x minus 8 kilometer per hour. So let us apply some common sense. Now the train is traveling from A to B the same distance at a lesser speed. Lesser speed is, its original speed is x kilometer per hour, but at this situation it is moving at 8 kilometer per hour less. That is, the speed is decreased. So if the speed is decreased, will the time increase or time decrease? Will the time increase or time decrease? If you want to go from Gubbi to Tumkur, usually you will be going at some 80 kilometer per hour in your car. But today something technical problem happened in your car and you are traveling at 60 kilometer per hour speed. Will the time taken by you to travel from Gubbi to Tumkur increase or decrease?
Increase.
It increases. Exactly, because as the speed decreases, the time increases for a constant distance. Right? If the speed increases, then the time decreases. Many of your friends will be telling you, my father was riding the bike at 100 km, 120 km per hour speed. We reached Tumkur just in 13 or 14 minutes. Usually in KSRTC bus it takes 40 minutes. But as your father is riding the bike at 120 km per hour speed, so time taken by you to reach Tumkur decreased because your speed increased. So now, your speed has decreased, isn't it? So therefore, the distance traveled is constant, but the time, does the time increase or decrease? Because speed is decreased, then the time increases, right? So distance is the same, it doesn't change, 480 kilometers. So time is equal to how much? So time formula we have, so time is equal to speed by distance, distance by speed, so that becomes t is equal to, distance is 480 by speed is decreased by x minus 8, so this is x minus 8. So time is here, right? I hope you got this. This is the logic behind these problems. You have to think, right? Think a lot. Now, we need to find the speed of the train. So, if you want to find the speed of the train, that is nothing but you have to find the value of x. So, therefore, let us set up the problem here. So, time taken is, when the train is traveling at a uniform speed of x km per hour and covering a distance of 480 kilometers. So, time taken is that is 480 by x hours. 480 by x hours. So most of the students I have seen, they will by heart this. In the train problem, we have to take the time as 480 by x, and in the second line, we have to take it as 480 by x minus 8. We will have to set up the equation. There is by heart the equation also. They will solve it, get the answer, take 3 marks. You got the marks, but you don't have knowledge. That is the main difference between students securing more than 600, 100 in mathematics, right, and those students who are getting those students who get less marks in mathematics also, but they excel in their PU classes because they have knowledge, right? So please be behind knowledge. So I have shown you very clearly how you get 480 by x and how you are going to get 480 by x minus 8, right? So now speed is decreased by 8 km per hour. So that becomes x minus 8 km per hour. So what is the speed of the train now? It is x minus 8 km per hour. But does the distance change? No, distance remains the same. Then we will calculate the time. So time taken is 480 by x minus 8 hours. So now I am going to ask you a very simple question now. Very simple question. Don't answer me in an urgency. Think and answer. Right? Shall I ask you the question now? Now. This is also time and this is also time. In the sense, it is some hours and this is also some hours. I hope you got it. This is time and this is time. Now, listen to the question here. If the speed has been 8 km per hour less, it would have taken 3 hours more to cover the same distance. So as the speed has decreased, the train is taking more time to reach point B. Right? So now, this is also time, this is also time. Now, tell me, think and tell me, as these two times are same or not? First question. Are these two timings same or not? No. These two timings are not same because this time is less because speed is more. This time is more because speed is less. So now this time is more and this time is less. So what is the difference between these two timings? The difference between the two timings is 3 hours, because if the train has travelled 8 km per hour lesser speed, then the train has travelled 8 km per hour less speed, then the time has increased. Here speed is more, that is x is more, x value is more, therefore time is less. So when you subtract this timing from this timing, the difference in time is 3 hours. So therefore 480 by x minus 8, this time is more, and 480 by x, this time is less. When you subtract the more time with the less time, the difference in time is 3 hours. Difference in time is 3 hours. Right? I hope you got it. Got the point? 480 by x minus 8 is more time, because the speed is less. As the speed is less, right, this time is more. In this case, speed is more, therefore the time is less. The difference between the two timings is 3 hours. Just imagine two trains starting from point A. One train moving at x km per hour, another train moving at x minus 8 km per hour. Which train will reach point B earlier? The train which is travelling at x km per hour will reach the point B earlier because its speed is more. After the first train reaches point B, then after 3 hours the second train reaches point B, because its speed is x minus 8 km per hour. It's less than that. Therefore it takes more time. Got it? So this is the equation which is set up. We have to solve this to get the quadratic equation. Right? So let us solve it. See, these type of problems you are going to get it for 3 marks. Right, let us solve this. So 480 by x minus 8 minus 480 by x is equal to 3. So let us take LCM for x minus 8 and x. That becomes x into x minus 8. So 480 by x minus 8 into this. X minus 8 is cancels. 480 into x is 480x minus 480 by x into this. X and x cancels. So 480 into x minus 8 is equal to 3. Right? The LCM process. 480x minus 480 into x is minus 480x. Minus into minus 8 is plus 8 by x into x is x square, x into minus 8 is minus 8x is equal to 3. Right? You have a beautiful chance here. Plus 480x minus 480x gets cancelled. So remaining thing is 8 by x square minus 8x is equal to 3 by 1. Please go with cross multiplication. So 3 into x square minus 8x is equal to 8. That's 8 into 1 is 8. 3 into x square is 3x square. 3 into minus 8x is 24x is equal to 8. We'll transpose this 8 to the LHS. So you are going to get 3x square minus 24x minus 8 is equal to 0. This is the required quadratic equation for the given situation. So when you solve this quadratic equation by any one of the methods, you are going to get the value of x. Here you have to consider x as positive because speed is positive here, because the train is moving forwards with an acceleration. Right? At a uniform speed it is travelling, therefore x is always positive in this case. So therefore when you substitute the value of, when you get the value of x, you will come to know the uniform speed of the train, maybe some 80 km per hour or 60 km per hour, something like this. Then we will only know it when you solve this equation. Right? So I hope you enjoyed the session today. So please practice problems So this is how the process of converting a given situation into a quadratic equation. Learn the concept. Don't fall behind scoring marks, right? That doesn't count anything in your life. Be with the knowledge. Ask why. Find out how, right? Ask the teachers. Ask me how it comes. Sir, how this happens, how it comes. Speak with the teacher, right? Then only you will gain knowledge, right? So with these things I would like to conclude. So stay home, stay safe, and keep learning. Thank you.